Hello internet, me again. This is going to be a bit of a quick, short, sharp video because I actually need to fit this into my van. So I have just made myself a Lifepo4 280 amp hour battery for my camper van. Surprisingly easy to do, but with most things it's easy when you know how. So I've spent a lot of time digging around on the internet trying to find out how to do them, what you're supposed to do, the do's, the don'ts, and so on and so forth. So I'm trying to put a little quick video together to try and explain this in more layman's terms. So these things here, there's 4 of them. These are called cells. So these are 3.2 volts at 280 amp hours. So we connect them together so that they add up to 12 point whatever it is, I can't think off the top of my head here, by using these things. These things are called buzz bars. What you basically got is your positive connected to your negative, your positive connected to your negative, positive connected to your negative, and that's your positive. So at one end of the battery, this is our negative terminal, and the other end we have our positive terminal. Now you'll also notice these little wires. These are called balancing wires, which I will get to in a second. Lifepo4 cells, when you charge them, expand ever so slightly. The trouble is, once they've expanded, you can't unexpand them, and it actually does harm them. So you need to contain them, I suppose would be the best word of putting it. So most people will just clamp them like this. Now, I'm not going to be putting this all in a box in the end, because of where it gets fitted in my van, it is actually completely protected. It's in its own box. But if you were to do this, I would obviously recommend putting sides on and things. So this is a bit of a 25mm ply here and here, some 10mm studding. Going to interrupt myself here. Didn't really explain this very well in the first part of the video, as I say, was rushing around a bit. The reason I've used 25mm ply is obviously when you clamp the batteries together, you're putting them under a lot of pressure. So you need to make sure whatever it is that's the both ends is not going to bow or buckle. Now you could use thinner pieces of wood and then put metal straps sort of over the end, but I happen to have some 25mm ply, so I thought I'd use it. But as I say, whatever it is that you use, because you've only got the 10mm stud either side, when you clamp it up, it's got to be able to handle the pressure. And in between the cells is, not that you can see it because it's clamped up quite well, is some what they call EVA foam, which is I think it's like a 1.5mm foam. It's just a very, very thin foam sheet. I've got some here actually. This stuff. As you can see, I've been making sticky pads. But yeah, so it's just very, very thin foam. Then you have what they call the BMS. It's either battery monitoring system or battery management system. It depends, obviously, who you talk to. I know that in my van, I'm never going to need to pull more than 60 amps. If I'm pulling more than 60 amps, I'm doing something very, very wrong. So there's no point in me having a whacking great big BMS. So that's just a 60 amp BMS. This is one from Daly. It's a very popular one. Some people say it's good, some people it's bad. You know, I sort of sorted it out. I've got it working. So far seems okay. So what have I done here? So I've got my big piece of wood, and I've got a nut here. Then I cut
in this piece of wood, I cut a hole for that to fit in. Not that you can see it, but on the back of that hole is a sort of base plate, so that fits in, and that is a very snug fit. And then we've got down here, this is our Bluetooth cable, which kind of goes up there, through there, and back out again, just because I needed to lose some of the cable. We have our thermometer, which is there, so that's just taped onto the top there. And then we have our balancing wires. So what is a balancing wire? Well, when you charge these cells up, you really want them to be all the same. So they should be all the same voltage, all doing the same thing. The balancing wires monitor the voltage of each cell. So you have to start off with a negative, which is there. Then we've got cell 1, cell 2, cell 3, and cell 4. So these thin wires are just enabling the battery monitoring system to know the voltage of each cell. And then what it does internally, it either charges or discharges them to get them to match. And the idea is you want them all to be exactly the same, which I understand is a bit of a fine art, trying to get them all to be exactly the same, but there you go. Then we've got our negative and our positive cable. As you can see, my full-on OCD is kicked in, and it's all been loomed correctly. There's a lot of people I see building these when I was doing my research on it, and they sort of throw wires around all over the shop, and just like, you're never going to be able to fault find if you ever have a problem. So that's obviously coming down here. So what we've now got is, now the way these BMSs work, if we go down to here, as you can see, I've been laser cutting stuff out again. So this is the battery minus terminal. So it's coming out the BMS. It's going into a big bolt. On the back of that bolt, it comes out. It bolts to the big black cable, which goes to a negative. Okay. This is because the BMS is the thing that turns off the battery, or the power, the current, if there's a problem. So it goes through there, and then it comes out here. Now these are just great big studs, great big bolts. And on this one, the positive, again, not you can really see it in there, but it's connected to that positive and just goes to there. So these are my two battery terminals. These are M8. I think these are M8. Yeah, M8 bolts. They've got washers on them and spring washers so that nothing comes loose, and it's all sort of clamped together. And then we've got down here somewhere, where is it? There it is. I'll show you it later, but that sits over that, which is going to be very hard to do one-handed, but basically that sits over that. So the only thing that's coming out is those two great big bolts. Okay, so it protects the BMS, but it means if ever I want to get to the BMS, all I have to do is undo a couple of bolts and take this panel off, then I can get to everything. Also, the design is, should I ever find that I need more than 60 amps and I want to change to BMS, all I'm doing is changing this, because that wiring's not going to change. So, as I say, it's all kind of done with bolts. Everything, obviously, you've got to be very tight. There is a whole area on the internet of people talking about, obviously, the compression. How much compression there should be. It's in the data sheet, but you need crikey, you need a spanner that I can't think of the name of it now. Torque wrench, that's the word I'm looking for. Torque wrench, so it can tell you that exact torque and what have you. I've just sort of done them tight until I feel they're right. But obviously, I would recommend that you follow the manufacturer's specs. I purchased these in the UK. Now, it's a Chinese supplier. I'll put a link in the description below. It's a Chinese supplier who has UK stock. And these turned up ridiculously quick, like 48 hours. It then took another 2 weeks for the BMS to turn up from China, but there you go. It's a very easy process. It really isn't that difficult. Bits of wood, some holes, some bolts, some screws, some cable ties, and yeah. I know, so this is a 280 amp hour. Right, sorry, I should explain that. So each cell is 280 amp hours, but when you put them in series, your voltage goes up, so the voltage gets added together, but the ampage stays the same. So in series, which is what this is, so it's a line almost, your ampage stays the same, but your voltage goes up because you're adding the voltages together. So this is a 280 amp hour. Now, I know that if I wanted to try and buy in the UK a 100 amp hour LiPo4 cell, would have probably cost me knocking on the door of £1,000. So this is 280, and it's cost me £540, I think it was. So the time I bought the cells and the BMS. So it's definitely worth doing yourself. As I say, if this was more kind of exposed, then I'd be putting sides on it. But I'll show you where it goes in the van later, and you'll realise why it doesn't need it, because it's all boxed up. Okay, right, so that's the first part of this video. There will be more added to it.
Okay, so in this part of the video, we're going to talk about the BMS, the battery management or monitoring system. I'm using a BMS from Daly. Now, some people say they're great, some people say they're bad. For me, as it was the first one I was doing, I had a look around. I thought, you know what, I think I can get my head around that one. I didn't want to spend weeks trying to understand an overcomplicated one. The BMS that I have is what they call a smart BMS, and I would highly recommend having a smart one. You can connect to it via Bluetooth, and you can change and set all your parameters. This does mean that should your requirements change, you can change the parameters, and you can also tweak them to match the requirements that you have and the cells that you've got for your battery. So you download an app called Smart BMS, and it will come up in the list. So we're going to click on that. And when you first load it up, you will come up with this screen here. So what have we got here? So at the top, we've got a scale telling us the SOC, state of charge, and it's currently at 94%. It tells me that the sum voltage is 13.3 volts, and we've got current has got a minus sign before it, and that's because it is drawing, or in this case now, 3.1 amps. We also have a charge MOS and a discharge MOS. So this means that it can charge and it can discharge. That will make sense a little bit more in a minute. And then the balance. So what you do in order to get into the setup is, let's delete that bit there first of all, hang on. We've got to click on this and you put in a password. Now I have changed my password, so obviously I'm going to blank this out. And now we've got a little bit more information. So we have num of temp 1. So this is the temperature sensor that's connected to the BMS, and it tells me that the temperature where the batteries are at the moment is 12 degrees. This is quite important actually for when charging, which once again, when we get into the full settings, you'll understand what I mean. Then we've got our 4 cells, and we've got 4. And you can see that the state of each cell. Now, in the first part of the video, I talked about obviously the balancing cables. That's exactly what they're doing. They are being able to check what the voltage is. So when you go to the top here again, your first one is maximum voltage. That is the maximum voltage of a particular cell. So 3.328, which is cell number 2. And the load voltage is 3.325. Now, obviously, what you want to try and do is get these as close as possible. You've got your average voltage is 3.25. And we've got a, as it sort of fluctuates, we've got a what they call a differential voltage of 0.02. Sorry, 0.002. That means there is 0.002 volts difference between the cells, accumulative. Ideally, you want that 0. But obviously, you've got to charge them, and then you get into the balancing stage. Okay, so some of that's going to make a bit more sense when I get into the settings here. So let's go into the settings. So the BMS, as I say, this is why some people called it management, battery management, and some people call it because it's kind of managing the battery, I suppose you call it. So you've got cell voltage high protect. Now, when you buy these cells, they should come with manufacturer's specs, and they will tell you that the maximum that these voltages should be. Mine maximum is 3.65. Now, I don't want to batter the hell out of my batteries, so I'm set them to 3.6. So this means, this one here, this top one, at 3.6, get rid of that, go away. There we go. 3.6 volts is the maximum that I will allow my cells to get to. And then you've got cell volt low protect. So that is the lowest I will let them get to before it cutting off. So this now means that when charging, when one of the cells hits 3.60 volts, it will stop charging. And obviously the other end of it, when it's discharging, if one of them gets down to 2.6 volts, it will cut off. Then you've got the sum of the high volts, which basically means the maximum that your voltage will be is 14.4, and the sum of the low is 10.4. Differential voltage protection. I'm not 100% sure, but I'm sort of about 95% sure on this. What that means is, if the differential between voltages, like we were talking here, so the diff voltage there, if that got to more than 0.25 volts, it protects. Okay, I'm 95% sure that's what it means, but the trouble with some of these things, they don't come with a lot of instructions. So charge current over protect. So I've set this to 28 amps. This means that it will never charge more than 28 amps. My charger can handle giving it 30 amps, and the BMS can actually handle 30 amps in. I just, once again, erring on the side of caution, don't batter the hell out of it. And once again, it's a 60 amp discharge, but I've set it to 55. Cell characteristics. So when you first get them, obviously you've got your cells. Now, my cells are LiPo4s. They are a rated capacity of 280 amps. The cell voltage reference is 3.2. That basically means when you get your cells, and obviously it comes with a spec sheet, it will tell you what these are. So your rated capacity is 280, and the cell reference, it would actually tell you that in the specs it's 3.2. Sleep waiting time, not a bloody clue, no idea. SOC, state of charge, it's telling you the state of charge. Now, this is where it starts getting, this is where I spent a lot of time trying to get my head around this. Balance open start voltage. Okay, so let me see if I can explain this. If we go back to this screen, I've got the cell volt high protect at 3.6. So that's the maximum it can get to. Balance open start volt means once it gets to 3.45 volts, it will try and start balancing. The balancing process is this, what we talked about here, this thing, this drift voltage. Okay, we want that when it starts charging, once it gets above 3.45 volts per cell, it will start trying to balance all these cells up here. And once again, at the top here, you'll see the little balance thing come on as well. So it's telling you that it is balancing. Okay, so what's actually happening is in between 3.45 volts and 3.6 volts, which is obviously 0.15 volts, it's going to do the balancing. The balancing should be done right at the very end of the charge. Okay, so you don't want to balance it too early. So once again, understanding this is kind of, so as I say, I know that my cell high volt protect could be higher, but I've set it lower. Therefore, I've set that to 3.45. A lot of people say don't start until charging till 3.45, and the voltage difference is when it should start balancing. So if there's a voltage difference of 0.2 or higher, then start balancing. So let's go on to this one. This isn't really that. So basically what this is telling me is that there's one board, there's 4 cells connected to it, and there's one temperature sensor connected to it. Okay, so that's basically what that is. Temperature protect, well, it's kind of fairly self-explanatory, but we'll go through it. So if the temperature of the batteries, or the temperature probe, should I say, is above 65 degrees C, it won't charge. If it's below 5 degrees C, it won't charge. You should never charge LiFePO batteries below 5C, okay? Then you've got the discharge high protect. So if the battery suddenly hits 70 degrees, it cuts off. And then once again, on discharge, if it hits below -20, it cuts off. The diff temperature protect, I think it's kind of basically saying 2 degrees either way. And the MOS temp protect, not 100% sure. Be honest with you, but I left it as is. Then we get to this one. So we've got basically here, we've got the 2 switches at the top. You can actually turn on and off the power. So if I wanted to, I could. I'm not going to because I'm sitting in the van at the moment. If I clicked the top button there where it says charge switch, it would stop the charging. Or disconnect charging, so it wouldn't accept the charge. If I click the discharge switch, it would actually turn the battery off. So there you go. So you've got a system reset, a factory reset, a zero drift current calibration. Once again, don't know, haven't played with it. I'm being honest about some of this stuff. It's kind of like, I've watched a million videos and other people have gone, yeah, we have no idea what that means. So, yeah. So basically what this does, it is protecting your battery. So the battery management system or battery maintenance system, whatever you want to call it, it is protecting your battery. Its job is to make sure that you can't overcharge, over discharge. You can't charge it when it's too hot, too cold. You basically can't do anything stupid with it. So the idea being is once you've set this up, you shouldn't really need to play with it again. Obviously, you will pop in now and then just to check what's going on, and, you know, so you can see your percentages. This last night was the first time I used it. When I arrived at the place that I stayed at last night, I was at 99%, and I had all sorts of stuff running last night because I was doing some bits and bobs. And this morning, with the heating that had been running all night, the fridge that had been running all night, it still only used 25%. This thing is bloody awesome. I really wish I hadn't wasted money on buying wet batteries to start with, because just useless. Right, so that's the BMS, and yeah, I think that covers that side of it.